we are going to study a new topic. The new topic is frictional force. So students, let's start. Okay. Okay, observe here what I am doing. This is one hand, this is other hand, right? Okay. I am sliding one hand over the other hand. I am sliding one hand over the other hand. Did you observe? I think you can also do the same activity. I am sliding one hand over the other hand. Therefore, the two hands are moving, right? Yes. Now, I am doing one thing. You also have to do it, okay? Whether it is moving, whether the hands are moving, what did I do? Yes, I lock the hands. So, it is difficult to move, right? Okay. Now, we can answer these questions. What is the first question? Whether motion happens or not when I slide my hand or palm over the other hand or palm. Whether motion happens or not when I slide my hand or palm over the other hand or palm. Yes, motion happens, right? Yes. The second question. Why does motion happen when I slide my one hand or palm over the other hand or palm? Why does motion happen? Why? Because there were no such difficulties for the motion to happen, right? Did you observe, right? So, you know the answer. The third question, whether motion happened or not when I locked one hand or palm over the other hand or palm. Whether motion happened? No. Right? I think your answer is no, right? Okay. Next, the fourth question. Why motion does not happen when I interlock the hands or palms? Why motion does not happen when I interlock the hands or palms? Why? Because due to the difficulties, that is what difficulty? I lock the hands together. So what happens? Motion cannot happen. So there is an irregularity present here. That's why motion cannot happen. So same is the case for the cause of friction. Let's see in detail. What causes friction? When we see any object, we can see the smooth surface, right? When we see any object, we can see the smooth surface. But when the same object is viewed under a microscope, it can be seen that even the smooth appearing object has rough edges. It can be seen that even the smooth appearing object has rough edges. Tiny hills and grooves can be seen through the microscope and they are known as the irregularities of the surface. It can be clearly seen in the picture. Did you observe the picture? Yes, the irregularities on the surface of the box and the tabletop. Did you see it? Yes. So when one object is moved over the other, these irregularities on the surface get interlocked, giving rise to friction. The same activity as shown you here. What is the activity? This is the case for the cause of friction. When I interlock, what happens? The relative motion is opposed, right? When I interlock these hands together, the relative motion gets opposed. So what happens? Motion cannot happen. More the roughness, more will be the irregularities and greater will be the force applied. So in order for the hands to move or in order for the relative motion to happen, what should I do? I should apply a force greater than this frictional force. I should apply a force greater than this frictional force. Then only what happens? What motion happens? Did you clear? All of you clear? So when we see any object, we can see smooth surface, but when the same object is viewed under a microscope, it can be seen that even the smooth appearing object has rough edges. Tiny hills and grooves can be seen through the microscope, and they are known as the irregularities of the surface. So when one object is moved over the other, these irregularities on the surface get interlocked, giving rise to friction. More the roughness, more will be the irregularities and greater will be the force applied. So in order for the relative motion to happen, we have to apply a force greater than the frictional force. We have already studied about frictional force. What is frictional force? When a body moves or tends to move on the surface of another body, a force is experienced parallel to the surface which opposes the relative motion between them, and this force is called frictional force. Clear? Okay, let's move on to the next section.
The first situation is when an object with a smooth surface is moving on a surface which is very smooth. Second, in which the object has a smooth surface and the surface on which it moves is rough. Or the object has a rough surface and the surface on which it moves is smooth. And in the third case, the surface of the object as well as the surface of the table is rough.
Did you observe the video, right? Okay, let's answer these questions. Which case has highest friction? Which case has highest friction? Options are case 1, case 2 or case 3. Which one is the right option? Yes, case 3. Why? It is having rough object and rough surface. Which case has lowest friction? Which case has lowest friction? The options are case 1, case 2 and case 3. Yes, the answer is case 1. Why? Because smooth object and smooth surface. Okay, let's move on to the next video.
Let's say there are two bricks on a table. One weighs 2 kilograms and the other weighs 5 kilograms. Now I apply equal force on them towards the right. Which brick do you think will go further? Remember that they are both kept on the same surface. And the surfaces of the bricks are also the same. On applying the same amount of force, you will notice that the lighter brick covered more distance than the heavier one. What does this tell us?
Did you observe the video? Okay, let's answer these questions. Which brick covers greater distance? Which brick covers greater distance? Options are 5 kilogram and 2 kilogram. The right option is 2 kilogram. Which second question or the next question? Which brick covers lesser distance? Which brick covers lesser distance? The options are 5 kilogram, 2 kilogram. Which one is the right option? Yes, 5 kilogram. So we can move on to the next slide. Did you observe these images? What is the first image shows? Yes, a person is pushing a big box, right? Okay, what is the second image? A person is pushing a trolley carrying that box. A person is pushing a trolley carrying that box. Okay, let's answer the questions given on this screen. First one, which case requires greater force? Which case requires greater force? The options are pushing a box, pushing a trolley carrying box. Which one is the right one? Yes, pushing a box requires greater force. Now, the next question. Which case requires lesser force? Which case requires lesser force? Which case? The options are pushing a box, pushing a trolley carrying box. Which one is the right option? Yes, pushing a trolley carrying box. Okay students, from these three videos and from these questions, What did you understand? That is, the factors affecting friction are, or the friction depends on, first one, on the nature of the two surfaces that are in contact. That you have observed in the first video, right? What did you observe in the first video? That is a ball moving on a surface. We have seen the first case, smooth ball, smooth surface. Second one, is two type, that is smooth board, rough surface, rough board, smooth surface. The third case was what? Yes, this rough board and rough surface. So on the nature of the two surfaces that are in contact, that is less irregularities on the surface, less friction. That we have seen on the first case. In the video, first video, we can see the first case, that is less irregularities on the surface, less friction. More irregularities on the surface, more friction. Clear? Okay. The next one. On the pressure between surfaces. On the pressure between the surfaces. We have observed in the second video, that is a same force applied for 5 kilogram and 2 kilogram, by 5 kilogram covers only lesser distance but 2 kilogram covers greater distance, right? You have observed, right? So that is the case here we have explained. On the pressure between surfaces, that is 5 kilogram has a greater weight, 2 kilogram has lesser weight. So the pressure between, that is the box and the table, the pressure between the surface is greater for which one? That is for 5 kilogram. So the pressure between that, or the weight of the box is greater for 5 kilogram. So the pressure between the surface is also greater. So what happens? There will be more friction. But in the case of 2 kilogram, lesser weight, so the pressure between the surface is also lesser. So the friction will also what? Lesser. So here we can say that on the pressure between surfaces, that is high pressure applied on the surface, more friction. Clear? And low pressure applied on the surface, less friction. Now we are moving on to the third one. On the area of contact, we have seen in the third slide what a man is pushing a box, a man is pushing a trolley carrying that box, right? In the first case, that is the man pushing a box, the area of contact is more. Area of contact means the area of contact between the surfaces is more. But in the case of second, that is in the second case, that is the pushing a trolley carrying that box. In that case, you can see that the trolley has what? Ball bearing. So the trolley has some rolls under the trolley. So it is in circular shape. So the area of contact between that ball and the surface, that is on the floor, is less. So what happens? Less friction. So here we can say that on the area of contact, that is, as area of contact is less friction is experienced. As area of contact is more friction is experienced. So what we have studied right now, the friction depends on the nature of these two surfaces that are in contact, on the pressure between surfaces, on the area of contact. Did you understand it clearly? Okay. So students, observe these images carefully. What are those images? First image shows trucking. Second image shows a person slipping on the banana. The fourth image shows striking a matchstick to produce fire. The fifth image is roller skating. Clear? Okay. Now, we are classifying it into situations which requires more friction or moderate friction, situations which require less friction. Okay, let's classify it. This is already shown here. For first case, that is trekking. We have already studied that by using this example, we have studied that trekking requires more friction. Trekking requires more friction, or trekking has more friction. For second one, a person slipping on the banana. Why the person is slipping on the banana requires less friction? Because what happens? The irregularities of the surfaces which are in contact with each other is less. The irregularities between the surfaces in contact is less. That is the reason why what happens, that boy is slipping on the banana falls down. Clear? Okay. Now we are moving on to the third case. Striking a matchstick to produce fire. We have already studied that it requires moderate friction. It requires moderate friction. The next one, the last or the final one, that is roller skating. Roller skating requires less friction. Why? We have studied that the area of contact between the rollers and on the floor is less, so less friction. Clear? We have studied today what we have studied. We have studied about what is frictional force, right? What are the causes of frictional force, right? Factors affecting frictional force and examples for more friction and examples for less friction. So I hope you have understood today's topic. That's all for today. Thank you.